Okay, consider this question. A small block of mass 100 gram is pressed against a horizontal spring fixed at one end to compress the spring through 5 centimeter. Okay, so this object is compressing the spring by 5 centimeter. The spring constant is 100 Newton per meter. When released, after compressing it is released, the block moves horizontally till it leaves the spring. So it is not attached with the spring. It will be compressing and then it will release and it will finally separate the spring. It leaves the spring. Where will it hit the ground? 2 meters below the spring. So this height is given 2 meters. Okay, so the question is, an object is there. That object is compressed by 5 centimeter, pressed against a spring fixed at one end, compresses by 5 centimeter, and then object is reaching the ground. So we have to find this length. This length, suppose we call this length as Z. Okay, this Z we need to find. Okay, so how do we find it? So first we will find the velocity of projection here. With what velocity it will be separating the spring. So for that, what we can write, I'm directly writing because we have already done many questions based on this. So for a spring, using conservation of energy, so whatever is the stored energy, the half kx square, or we can directly write it like this: delta U equal to delta K. Okay, or minus delta U equal to delta K. The decrease of potential energy equal to increase of kinetic energy. So decrease of potential energy spring equal to increase of kinetic energy. So decrease of potential energy spring is how much? Half kx square, because it was compressed by 5 centimeter x. The x was 5 centimeters, so it was compressed by half x. So half kx square energy was stored, and that energy is getting converted into half m v square. So how much is v? So v is equal to x under root k by m. So this is the velocity of object just after release. After conservation of energy we have found. So this is velocity of object just after it separates, from spring. It separates from spring. Okay, so this is the velocity. And now after separating, it becomes a projectile. So after that point, after separating, we will solve separately as a projectile. After separating, it becomes projectile. Object is projectile. Okay, horizontal projectile or half projectile. So if it is projectile, the vertical direction displacement, how much displacement it is covering? H equal to half gt square, because there is no vertical velocity initially. So how much time it will take? The time taken will be 2h by g under root. So h is how much? 2 meter. 2 into 2 meter divided by g is 10. So this is the time. Okay, in this time, how much displacement it has traveled? So displacement z will be equal to velocity v into time t. So velocity v is this one, under root x by k. So we can find the value also. So 5 by 100 in centimeter. This is 5 centimeters. 5 by 100. K is how much? K was 100 Newton per meter, and m is how much? 100 gram. So we can write it 5 by 100 and root 1000. Okay, so this is the velocity of the object. So that we can use. So if we use it, 5 by 100 and root 1000. Okay, so this is velocity, and time is 4 by 10. So if we solve it, 5 by 100 and in root it is 1000 into 4 by 10. So 10 cancelled, so 400. So 400 root is how much? 20. So 5 into 20 by 100. So that we are getting 1 meter. Okay, so the object will land at 1 meter distance. Okay, object will land at a distance 1 meter from the point below of the object. Okay, so this is the answer.